Today we talked about similarities. I was planning to do practice exercise today, but I thought maybe just do one basic and then just work on. Uh, since we don't have time, we'll just do the most basic thing you have to remember all the way. The end is angle side ratios. Always remember that when you're taking two triangles to be similar, to take their angle they're similar of and their opposite side as their ratio. This is A. So let's just make a nice little diagram, I think. This is for any similar triangle, by the way. It's not like the triangle diagram I just showed. We take it as any similar triangle. Two similar triangles where their angles are the same. We take the angles here. So now let's label this one as B, I think. B. So always remember it's, depending on how you write it, it's B by A. You take the angles opposite angles, right? And this is if the angles are similar. You take this angle, that's opposite side, let's call it C. Let's call it D. Take this opposite side. So it's taking this way the format it's going. Okay, this is just one example. Notice how I'm following a certain pattern, like having the reds on top and the whites on the bottom. Always have it in this way where it's same. Do not make it different. You can even, if you're wondering, yes, it's completely fine to write it like this. Something like this. This is also fine. This is correct. This is correct. Both of these give you the right answers. Let's do some practice problems that are a bit tricky, I think, because most practice problems are not that hard to solve, but some of them are quite tricky. So, yeah, I'll be giving a few of the practice problems that I think are quite hard. So let me see if I can find some. It's best to do all, so I think that's what I'm going to do. Yeah, let's do that. And I'm also going to show you a few quick life hacks to just go through them. So, let's start with the first one. So let's draw the triangle, I think. This is not, you guys can't see the book I'm using. Three X, this is P, this is A, this is C, this is Q, this is B. Oh, whoa, that's weird. This is B, this is 6, and this is the 2. Right. We're told to find X. So a little life hack I would recommend using is if you understand it well. This are corresponding, so it's obviously the ratio of these sides, not these sides, right? Not this side, the 6 and 2. It's small one it's 6, for the big one it's 6 plus 2. These two addition because it's the whole triangle. So again, let's take the ratios, I guess. So we take the value ratios and not waste our time. So we have A, P, Q, C. Opposite is 6 divided by A, B, C. Its opposite is 2 plus 6. Remember one thing, if it's y is 2, I'm not only accounting for this 2, I'm also accounting for the total length. If you're confused what I'm doing, see this whole triangle. There's the total length. That's plus. So 6 divided by 6 plus 2 is 8. This is equals to small 1 by the big 1. Now, if it's already mentioned that the triangles are similar, it means just take the ratio of any of the two sides. So we took this side, and we take that side, this side, and that side. So we can find the value of x, right? So 6x is equals to 24, x is equals to 4. There you go, that's the answer. Let's do another one. This one, I think I should have done this one first. This one feels much easier than I just showed you, but it's fine. It is what it is. B, we have a C, Q, we have a P, we have a 6, we have a Z, we have a 6 in here again, we have an A, this is 10, this is 15, this is Y, since the unknowns in red, I think Y, and oh, that unknown right there on top is Z. So we totally find Y and Z. Alright, so first let's write down the obvious side ratio that I think is a number. It's this ratio. We see it. This angle ratio, this big angle ratio. So we got, how I like to say it, small, the big one. This is equals to, say this side, I guess. Start with Z. No, let's start with Y. I think Y feels much easier. Small by big. That's what I just did. This opposite side, this total opposite side. Okay, so we can find Y from here. This is equals to, see this opposite side, small opposite side, and big opposite side. And since both of these are just equals to this, we can easily find out the values. I'm not going to show that, it's pretty easy. But I think I'm going to show this one that I found, and I think it's pretty tricky. Okay, so a quick reminder, the maths I'm showing you this in all level examinations are never this hard. It's just here, it's just this difficult. So, say we see this one, I think. Yeah, sure, let's start with this one. We have sort of the bank. Yes. Triangle like that. Okay, a triangle like, oh, that triangle like this. Anything else? Oh yeah. That. Okay, so this is parallel, this is parallel. There's a lot of stuff here, a lot of information we have. We have to find this D at the bottom, this C on the side. We're given 4, given 2, we're given 8, we're given 5. Is there anything else given? There's nothing else. Right, cool. So this is A, C, B, C, P, and Q. That's a weird looking 4. Let me just write this correctly. There you go. Okay, so how do we find these values, right? We can see that there are parallel lines, right? Parallel lines. There's, it's not like this one, by the way. It's not like, whoa, my whiteboard's, let me just click log in. Quick, technical difficulties. I don't know why that happened. There's a weird bug. Okay. Oh, whoa. What is that? That's a weird feature. I can't scroll easily. Alright, nice. If I scroll too fast, I'll be kicked out. Cool. Alright. Let's see what's going on here. Okay, so okay, we do see a big triangle and a small triangle. I think we should do that first. So we take this small triangle, we take this big triangle, and take their area ratios. So we're left with taking the small one on top by, okay, I think it's better if I write it like this, D, there we go. This is equals to, what else do we have? What else we have similar? Alright, we have this angle, this triangle similar, what I'm talking. Or, let's see. Yeah, we have this triangle, this triangle. So we have this triangle and this upside down triangle to be similar. So if these triangles are similar, what do we know? What information do we know from this? We know this opposite angle side ratio, opposite angle side ratio. Alright, we know that these are parallel lines. So this angle and this angle is the same, right? Because alternating. So that value is going to be 4. Oh. Okay. Oh, is there any other angles in here? I kind of left this just like that. Wait, I made a mistake. This, and this, right. This is parallels. This and this is the same. Is there any point in using this? Do we get any values? No. This method doesn't work. So you have to use the other method I was thinking of. This triangle and this triangle. So by first taking the opposite sides, I guess, let's take this angle and this angle. Or I think we start with the alternates, I think. This angle and this angle is alternate. So that's opposite side ratio. We'll start with small, I think, small by big. This opposite side ratio is 4, divided by this opposite side ratio is 8. This is equals 2. And this angle is alternate to this angle. So this opposite side ratio is, okay, starting with small again. It's 2, and for this one, it's C. Alright, cool. This is equals to, what else we have? The remaining side, which is the big angle. So we start with the small one, then the big one. The small one, which is 5, and the big one, which is D. So now we find out the values of C and D easily if we can simplify this to 1 by 2. So it's half is equals to 2 by C. This is equals to 5 by D. So C is equals to 4. D is equals 2. 10. There you go. That's how you find the values for this one. Oh my god, what is this new feature, bro? So annoying. This whiteboard is tweaking out like a lot. Like, moving it too much to the right does that? That's cool. What in the hell? That is so annoying. This wasn't the feature, by the way. This is a new feature. It's so annoying for me as a laptop user. I have to now slowly move to that one side. If I want to move to the left, I move it slowly. So we have this, right? Okay. Oh my god, that is the 4th time that has happened. Bro, I might just change the applications to OneNote if this keeps continuing. Right, let's do the next one. Next one we have is upside down triangle one. Should I do this one? There's a lot of them. You know what? I'm just gonna continue because these ones are pretty complicated and pretty important. That just finish. Let me just do the diagram. This straight line here. Well, I'll just draw it and then like show it to you. It takes some time. Okay, this is the triangle. So let's solve this. Now, if you think about it, you can break this down as two triangles. So just go to select thing. Okay, now let's not do any of that. Let's just write. So select. I'll just draw it out again. We can imagine this. So this one, this one. This is 14. This is 10. Is there any other information do we know? There's no other information, right? Nice, perfect. So this is C, this is S, S. No, that's not C. This bottom one. This is C, this is S, this is B. Oh, wait, no, this is S, this is C. This is A. Okay, so now we have to. Okay, the only numerical value I can see is 3, but you know what? Let's do all of them instead for this one. For the sake of it. So first we have, of course, the value ratio with the small with the big. 10 by 14. Small ratio is there a midpoint? Oh yeah, there is. It's R. I didn't see that. It's AR by the big one, which is AS. Now, for the other side, we have small one, which is AB, by AC. Let's keep this as it is. Now let's do the other triangle. Remember, it's like a smaller one. It's like a, not smaller, a bigger one. So this bigger one, let's draw this one out. This is the one with the E, by the way. We don't know this E. What in the hell just happened? Okay, cool. Now I'm gonna question what just happened. Something happened. Alright, E. 18. Alright, cool. This. What else? A. P. R. Q. S. Okay. So let's do this. So this E value we don't know. This 18 value we do know. Oh, let's just do this thing. Let's keep this in the same format as well. So small with big. You have it here, right? So the E is divided by 18. This is equals to this one, which is AR by 8S. Let's stop here for a second. If you remember that we already have AR is equals to AR. Let's notice how there is a common. Since we know AR and AS's ratio is 10/14, we can write this whole part as E by 18 equals to 10/14, and now we can easily find out what the value of E is. So, oh my god, that's the second time that has happened. Probably gonna switch to OneNote for the next videos because this is getting a little frustrating. Right. Slow. Can't really move to the left anymore. Oh my god. I have to now trick it by moving on diagonals. Anyways, let's go to the next question. Right, again, I'm just gonna pause the video because it's gonna take some time for me to write it down, so yeah. Okay, so we have this. So now, let's solve for G and F. Right, let's see, do we have any similar triangles that we can utilize? Is there any parallel lines? Okay, I see a triangle. This is a bit hard to see because it's actually rotated really badly. So let's just redraw this triangle I just saw, right? This, that, like this. This is our G line. This line. Fine, that's our G, right? And line parallel. And that is 6. This is F defined. Now the labeling. This top is C. This is E. This one is 10. This is B. This is A. This line are parallel. Let's see what we can find out from this value, right? Let's just try, right? These two triangles. So let's take the small divided by the large. Right, this angle, small divided by the large. Is there any other you're left with? Is there any? Oh, there is one more point I missed. F. Okay. Then small. C by the big. Like that, something like that, right? So now what? We don't have any values. That means we're done with that triangle. Is there any other triangle? Yep, I see another one. Right, let's do that one. Now it appears to have some values too, so that's nice. So what's the second triangle I see? Well, the first triangle, by the way, I should highlight which triangle I'm talking about. The first triangle I saw was this triangle. The second triangle I'm going to see is this triangle. Notice it's a bit rotated, all these triangles. If they are not rotated, it would have been easier, but it is what it is. So this other triangle is, if I draw it out, looks something like this, like an obtuse angle triangle. Okay, this line is parallel. Okay, let's start putting in stuff. This is B, this is F, this is D, this is C, this is E, this is 6, this is 10, this is F, this is 8. Now, we can easily find some stuff from here. Firstly, I should mention that these lines are in fact parallel. So, firstly, small by the big. This is equals to this angle side small side we have is 10 by the big one, 10 plus f. Now, finding the other side doesn't really matter anymore since we already found the value for f. This appears to be a connected method. Here's why. Once you find the value of f from here, you substitute this value of f into here and you'll find g. So that's pretty much what you have to do. I'm not showing much, I'm just showing the main breakdown until you get to this point. So yeah, that's pretty much all for that. Let's do a very specific exercise. So to finish off our similarities. Let me find this first, I think. Okay, I'll find this very tricky question and just give it here. Okay, this is from a past paper, and I've chosen this one because it has something that's a bit different from most other questions. I'll show you in a moment what I mean. So, firstly, we have this, right? We have all this and everything. So you have to first tell us, you have to prove that how triangle A&M is the same as NBL. Wait, let me still double check the question and see if I missed anything. Okay, this is right. So the main idea is, it's given as AN is, so AN to NB has to be 2 by 3. In ratio. So if that's the case, right, we know this. So AN is 2, this is 3 ratio. Not the actual one, it's the ratio. Then it says to find the ratio of NM by BC. So NM, what is NM? NM by BC. These two lines are similar, right? NM by BC. So what can we see from this? Oh, we can use a similarity. We can use the similarity that, okay, we can use a similarity that yeah, we can use similarity. So we use this angle and this angle, so we use small by big is equals to NM no way, this is not how it works. This is a tricky one. Pretty tricky. Okay, I'll get to this one in a moment. Wait. Okay, so... Oh, I made a mistake. I made the most silliest of mistakes. Big with the small triangle. I forgot that this means addition of these two. So, it is exactly what I think it is. So, it's NM by BC. This is equals 2. The small one by the big one, which is 5. So the answer is 2 is 2, 5. It's not 3, it's 5. Because you're supposed to add 2 plus 3 plus 2, not just 3. When I was taking the triangle, I made the silly mistake of only taking in 3 and not taking in 2. Oh well. Anyways, next. This is to find the area of A and M. A and M. A and M. A A and M and NBL. So there's two ways to think about it. Is a side ratio squared, right? The idea is side ratio squared. So what side ratio are you going to take? It's the one with the value, right? So we take this A and M being the top one, by the bottom, the whole square around it, we get 4 by 9. This gives us 4 is to 9. If I'm correct. Yep. And now the final one, which is okay. Before anything, I think I should explain what I mean by what the hell I just did here. If you don't know, for finding ratios of areas in Similarity, there's two ways. It's either the base ratio or the side angle ratio. You can take any side and put it in a ratio. Just take the values and put them in a whole square accordingly. Pretty much that's it. Okay, now let's go to the next one. The next question says to find the area of A and M is 2. So A and M is 2. NMCL, that. So A and M. We already know A and M's ratio, right? A and M, we know that. A and M is what? 4. So, A and M is 4. We know this is 4. We also know that this ratio is 9. So what is this remaining ratio? Right, that's the question. We have to find out what this remaining ratio is. Is there a way to find the remaining ratio? It's a little tricky. So, if you want to find it out, then find it out. But if you think about it, do we know the total ratio, the total area, giant area? Well, we can find out the giant area by taking in the ratio of the giant with the small. So let's take the ratio with 4 by, because A and M is the most common here, so let's take A and M is to the big one, which is A, B, C. What is A and M? A and M is 4. What is A, B, C? Well, A, B, C, we take the side ratios, remember? Okay, I made a slight mistake. Do not just subconsciously put 4 here. Take it by side ratios. So we take the small side ratio by the big side ratio, the whole square, we get 4 is to 10. So the whole area is 10. If you think about it, if the whole area is 10, that means by ratio, the remaining area must be these two areas subtracted from the 10. So A and M, we already know A and M is 4. NMCL is 10 minus 4 minus 9. If I'm right, let me double check. Oh, mistake. Silly mistake. Again, this is supposed to be 25. Bad. Not 10. 25. There we go. Right? That's why I was wondering why I was getting a negative area. Alright, this would give me 21 minus 9, 4 ish 2. This gives me 4 ish to 12, or 1 ish to 3. That's the answer for this area thing. Right? Right. Now there's one more I would want to solve, and for that one, I'll be actually pasting the image of it. So let me quickly find it and just paste it here. Okay, so this is the math right here. So let's solve it. Just quickly make things easier for me by making it to max. There you go, much better. Right, so this is all the information given. It says to show that triangle PQR is similar to PML. Now I may have noticed that other than this one angle, none of the angles are similar. Well, the other way you can prove the two triangles are similar is by seeing whether the base ratio is the same. So how do you find the base ratio? Well, the base ratio is very simple. Let's take any two base ratios. No, not that. Base ratios to see whether they're the same or not. Yep, exactly. So how do you find this base ratio? If first, I think it's good to just see what information we have. So these two addition becomes 12. That's 15. This whole thing becomes 15. This is 10. The big triangle is 15. This is 10. This is 4. This is 6. The small triangle you see there. So, okay, my bad. So it's not gonna be side. It's not gonna be my bad. It's not base ratio. That's side ratio. I mixed up with the area. Anyways, so how it works is if the side ratios have to be the same. So the side ratio to be the same. So say we have take the small triangle 4, 9. And you can take any side, right? So let's take a random side. Let's take 11. 4 by 11. No, not 11, my bad. 4 by 15, right? Or I think that's not good because I can't simplify. Maybe let's take 4 by 10. This has to be equals to 6 by 11, right? So let's simplify this. I don't think we can simplify this any further. Where's this all? Okay. I'm not supposed to do this. I keep forgetting that you take the whole thing. This simplifies to 2 by 5. This simplifies to 2 by 5. 2 by 5 is equals to 2 by 5. Proof. Since the side ratios are the same. To find the numerical value of the area of PQR, and PML. Since we proved they are similar, we take any side ratios squared, right? So area of PQR, it's something whole square, yeah. So something whole square. So we know that it says PQR. PQR's opposite side is in fact 10. That's PQR, yeah. And PML's opposite side ratio is 4. So yeah, 4 by 10 by 4, this implies 2 by 5. So that's 25 by 4. That is our answer. Alright, given that the area of the triangle PML, oh, we gotta clear a bunch of stuff up. Just clear many of the stuff up, right? Okay, it says the actual triangle's area of this is 6. Now remember, this is the ratio, 25 is to 4 of PML. PML is the bottom one, so that's the 4. So what is the total ratio of the quadrilateral LMRQ? If we know what the total real ratio is, we should know what this is. I hope you guys remember that scale thing. Remember all that scale? Hopefully you guys remember how that scale system works. It's exactly that. It's exactly that. So we know this as 6. We don't know this, right? 4x equals 5. 6x equals 2. Okay, so what left with this? This becomes 37.5. So that's the total triangle, but not the quadrilateral. What is the quadrilateral? That is this total triangle's area minus this 6. So the total triangle's area minus the 6, we get 36.5. That is the answer. Turns out it's a bit complicated, but if you keep your mind cool, we can solve most of this. So yeah, good lord again. Anyways, that's for today. I'm gonna take a shower. See you later. Bye bye.